Hey guys, in this video we are going to cover this section and sandwich theorem. What else? Uh, Rule of limits and sandwich theorem. Squeeze theorem means the same names or sandwich theorem. We will talk about that one also. What else? What else are alternating sequences? So we will cover three things: sandwich theorem and alternating sequences. Right, this one, yeah, and this one here. So suppose we have two sequences like this. Now we are going to find the addition. So when you add, so these are the general terms of this one and this one, right? So when you add these two values, you can generate another sequence, right? So if you define C, wait a second, where's my pen? Here we go. All right. So C sub n is equal to sum of A sub n and B sub n. So here we generate another sequence Cn, which is the sum of these two elements. So C1 is A sub 1 plus B sub 1, C2 is A sub 2 plus B sub 2, and so on. So the limit of sum of these two sequences is this. The limit of sum of these two sequences is equal to sum of limits of A sub n and B sub n, right? So you can show this one. In this course we don't provide a proof for that. I think in PM2 note 1 we have proved these things, right? And also you can define the difference of these two sequences like this. So as follows, and D sub n is equal to A sub n minus B sub n. Then D sub n, this one is also a sequence. Then we can talk about the limit of that sequence. The limit of that sequence is the distance between the limits of A and B, right? So if you have a constant sequence like this, so say for all n, so this one is equal to C. So this one is a constant sequence for all n. So A sub 1 is equal to C, A sub 2 is equal to C. All terms are, this is called a constant sequence. So this sequence does not depend on n. So the limit of this sequence here, look at this, limit of a constant sequence is equal to itself, right? And so if you multiply this sequence by a constant C, then you can generate another sequence. So let me write that down for you. C times A sub n. This is another sequence. So when you talk about the limit of this sequence, so we know that the limit of A sub n is we don't know, So here uh, you have the constant. So because this constant does not depend on a value, you can take it out from the limit side. Otherwise you can take that one, you cannot take that one from this limit, right? So because that c constant does not depend on n, you can take it out. Then the limit of this one is equal to c times the limit of a sub n. So now we can talk about, if you have two sequences, we can talk about the product of these two terms. So you can generate another sequence by multiplying each element in the sequence. These are there. Yeah, this one. So this will gives you a new sequence. So the limit of this one is same with the limit product of limits of a sub n and b sub n, right? We can prove these properties, these rules, but in this course using the definition of epsilon, that what we have learned today, right, in the morning in the lecture. So we can, by using that definition, we can show that this one is same with this product of limits, right? And if and we can generate another sequence by dividing um, one from, so bn by bn, yeah, so by dividing an, so saying a sub n is divided by n, so this will generate another sequence. So here, if you want to define this kind of sequence, so here bn should not be equal to 0, otherwise you cannot define that for all n belongs to natural numbers, right? Otherwise you cannot define this ratio, this division, right? And assume that the limit of bn is not equal to 0, right? By assuming these things, by assuming this one and this, then we can talk about the limit of this rational term, right? The limit of this rational term is equal to the limit of a sub n divided by the limit of b sub n, right? Okay, so there's another one. If so, suppose we have a continuous function like this, and the limit of f of a sub n is equal to f of the limit of a sub n. So you can interchange, you can take this limit. If the function is continuous, you can, wait a second, if the function is continuous, you can take this bit inside of the function f of limit then goes to infinity a sub n. So we know that as n tends to infinity, a sub n approaches L. So this one is same with f of L. That's why you get this here. Think if this is true, whenever f is a continuous function, right? This one is, you can take this limit inside of a function whenever f is continuous. You can show this one also. Now using those rules of limits, we determine whether we determine if the following sequence converges or diverges, right? So here we have this one. So we want to determine if the following sequence converges or diverges. If it is converges, find the limit. All right. So just simplify that. Square root 1/3 square root here 2 plus 1 over n here. So n is the common denominator. So you can consider separately 2n divided by n plus n over 1 over n. So you can close that off. Then you left with 2 plus 1 over n, and that one is that term, and minus 1 over n. As n tends to infinity, this term approaches 0. As n tends to infinity, so here square root, not square root, third root is continuous. Then you can take the limit inside. Then this term, as n tends to infinity, this term goes to 0. Then you end up with having, so limit of this one is equal to 2 to the 1/3 1/3 minus 0. That means you get 2 to the 1/3, right? Okay, so now let's talk about this squeeze theorem or sandwich theorem. So suppose we have three sequences, x sub n and y sub n and c sub n. These are three sequences, a sub n and b sub n and c sub n. These are three sequences so that the value of a sub n is less than or equal to b sub n is less than or equal to c sub n. This is true for all n after n naught, right? So as we know that, and we are given this property too, so we know that as n tends to infinity, an approaches L and Cn also approaches L. Then what happened? The intermediate sequence, so this one Bn. So here Bn also approaches L as n tends to infinity, because this is squeezing. So Bl, so this one here, b sub n also approaches L. This one is easy. Not going to prove this because this is an implied course, right? Do an exercise. So let's find the limit of the following sequence: 2 to the power n divided by factorial n. So this sequence, so you can show that So this term 2 to the, so this can be expand as follows. So you look at this. So 2 to the n divided by factorial n can be written in this way too. So factorial n is 1, 2, 3, and n minus 1 times n up to n, product of these values, these numbers, and 2 to the n is 2, 2, and there are, so we multiply 2 n times, right? So and this would be, so if n is greater than or equal to 2, you can prove this one by using mathematical induction. You don't need to, and this one is trivial, right? So this term is less than or equal to 2. We'll not just notice that here these terms less than or equal to 1, less than or equal to 1, less than or equal to 1, right? Whenever n greater than or equal to 2, so then 2, so this one is less than or equal to 2 times 2 over n. I hope you understand. And this is positive all the time. 2 to the n over factorial n less than or equal to 4 over n, and we know that this one is positive, non-negative, this one is greater than or this one is greater than or equal to 0. Then take the limit. So we know that as n tends to infinity, this term becomes 0. This one is bounded by this one, so this is the bound, right? This term becomes 0 as n tends to infinity. Then what happened to this term? By using sandwich theorem or squeeze theorem, this term also approaches 0 as n tends to infinity. By using squeeze theorem, this term also approaches this. So now we are going to talk about alternating sequences. So with my lecture, I talked about alternating sequences. So for instance, if you have 2 to the negative 1 to the power n, so this sequence is an alternative sequence. So it is alternating between positive 1 and negative 1, right? If the power is even, the result of the term is positive 1. If the power is odd, the term is negative 1, right? Like that, alternating sequence. So when it comes to convergence of that sequence, so you have to check, you have to consider the magnitude of this sequence, right? If the magnitude, the modulus of that sequence, so here, so if you have an alternative sequence, so say this is an alternative sequence, a sub n. Now you have to ignore the sign, that means you are taking modulus, and check whether this sequence approaches 0 as n tends to infinity. If this one is true, you can say that this alternative sequence converges to 0, right? here they provide some examples. So here you have this term negative 1 to the power n. That means you have an alternative sequence. It is alternating, and as I said before, you have to consider the magnitude of this. So take the modulus of that, then this one, and determine the limit of this modulus of that. The limit is equal to 0. That means this alternative sequence converges, right? As well as this. Look at this second one. Here, therefore, it is the second one. If you consider the second one here, if you take the magnitude, if you consider the magnitude of this sequence, so you will get 2n plus 1 divided by all divided by n. So when you simplify this, 2 plus 1 over n, as n tends to infinity, this term 1 over n term approaches 0, but this term approaches 2. That means as n tends to infinity, so this one, the modulus of this one approaches 2, because it is non-negative. 2 is non-negative. That means this alternative sequence does not converge, right? Alright guys, that's all what I would say in this video. I will talk about bounded sequences, what is monotonically increasing, monotonically decreasing. Let's know about those things. So you have to have a basic idea about these things to do our studies, right? Otherwise you won't understand many things in numerical analysis. So I know pure math students know about these things, but applied students have to know these things clearly. If you have any doubts, you can ask questions when I come online, right? And you can contact our tutors to seek help, right? They are happy to help you, right? See you guys in my next video.